Hello everyone, welcome to my channel ACKM Education. Hope all are you doing well. Today I shall discuss about the spectrochemical series, and this is very important topic because of if you don't know about weak field ligand and strong field ligand, and which one is specially weak field, which one is specially strong field, then you cannot find out the paramagnetism or magnetism or any kind of CFSE value, CFT, VBT. Everything is depend on the weak field and strong field concept. Okay, so this is the spectrochemical series where we can see that iodide is less than bromide, less than sulfide, that is thiocyanate, and chloride, NO3 minus, F minus, OH minus, C2O4 2 minus, oxalate, and water. So from this, from iodide to water till this, all the ligands are weak field ligand. Okay, all the ligands are weak field ligand, and after that, from isothiocyanate, methyl cyanide, pyridine, amine, ethylene diamine, bipyridine, nitrite, methyl cyanide, and that is CO group. CO group means that is carbonyl group. So these all are the strong field ligand. Okay. So how to remember? What is the short trick to remember of weak field and strong field? Let us see. If the donor atom is halogen, that means fluoride, chloride, bromide, and iodide all. Oxygen, that means it is in oxide form or oxygen having lone pair. Okay, and sulfur. So if the donor atoms are halogen, oxygen, sulfur, then the ligand will be weak field ligand. Okay, because you know that in oxalate also there are two oxide O minus ions in oxalate. Structure of oxalate. So oxygen is donor atoms. These two oxygens are donor atoms here. Okay. In water also oxygen having lone pair. Okay. And in thiocyanate, sulfur coordinates with the metal ion. So the bond metal sulfur bond is there in case of thiocyanate. So these all are the weak field ligand where the donor atoms are halogen, oxygen, and sulfur. Next, if the donor atoms are nitrogen, so these all are weak field. Weak field. And if the donor atoms are nitrogen, carbon, then we can say the ligand will form strong field ligand, because you know in NCS isothiocyanate metal coordinates with nitrogen atom. In case of thiocyanate, sulfur atom, and in case of isothiocyanate, nitrogen atom. In case of CH3CN, carbon will be coordinated with metal atom. In case of pyridine, you know the structure of pyridine is this type of structure. So nitrogen is having lone pair of electrons in case of pyridine. Okay, so nitrogen is donor atom. In amine group also, ethylene diamine also, if you see ethylene diamine, structure of ethylene diamine, CH2 NH2 CH2 NH2. So nitrogens are having lone pair, and these are the donor atoms. In bipyridine also nitrogen atom. Nitride and nitrate. In case of nitrate, we have seen it is weak field because the donor atom is here oxygen, and in case of nitride, the donor atom is nitrogen. So metal nitrogen bond is here, and metal oxygen bond is there. Okay. In case of methyl also, carbon is the donor atom. In case of cyanide also, carbon is donor atom. In case of carbonyl also, carbon is the donor atom because metal carbonyl. This type of coordination will be there. So this is the short trick to remember, that depends on the donor atom. What is the donor atom in ligand? If the donor atom is halogen or halides, oxygen and sulfur, just remember these three, then we can say the ligand is weak field ligand. If the donor atom is nitrogen and carbon, then the ligand is obviously strong field ligand. Okay. So this is very important topic. So this is the very important topic because otherwise you cannot predict the value of you cannot calculate the value of spin only magnetic moment. You cannot predict the CFT structure or VVT structure without knowing the weak field and strong field ligand concept. If you like my video, please do like, and if any doubt, please comment in comment section, and please subscribe my channel, otherwise you won't gain any further notification, and please press the bell icon to get notification. Please subscribe, otherwise you won't get the next topic what we'll discuss in our future classes. Thank you for watching.